There was a time when I was a kid, I used to love making small circuits, especially with LEDs, which used to run on AA batteries or such similar alkaline batteries. The problem with these batteries was that they used to drain pretty soon. Well, in this video, I will help you learn how to use power supply directly to the AC mains without damaging your circuit. First, we need a transformer, as in a step-down transformer. As the name itself indicates, a transformer transforms voltage. Here, a step-down transformer, meaning from higher voltage to a lower voltage. So let's say I need a 5 volt DC supply for my tiny circuits. So I can use a step-down transformer from 230 volt to 5 volt AC. However, I shall use a transformer of 12 volts as output voltage. Why? Well, I'll get to this point later. So a step-down transformer with 12 volt rating is what we will be using right now. If you have any previous experience in electronics, you may know a transformer's input and output are both AC voltages. So next step is to convert this 12 volt AC signal to DC. To do this, we need some diodes. Let's use a simple IN4007 diode. A diode basically conducts in forward bias condition and acts as an open source during reverse bias. Let me demonstrate this in a more simple way. This basically is the symbol for diode. This here is the positive end, this will be the negative. Now if I have a circuit like this, my LED will glow. If I reverse the polarity, then my LED does not receive any voltage. Since my diode is reverse biased, basically forming an open connection like this, which does not allow the current to flow through the LED. Now since our source voltage is AC, let me just replace my battery with an AC source. Since AC stands for alternating current, this is how the voltage varies with respect to time. Now in our case, during the time interval of the positive half cycle, this diode is forward biased, meaning your LED will be glowing. But during the negative half of the cycle, this diode is reverse biased, resulting in an open circuit here, consequently turning off this LED. So technically your LED will be blinking every 0.02 seconds, assuming your source frequency is 50 Hz. The blinking frequency may be small, but it's still noticeable. We don't want this to happen. To get an output which has voltage in both positive as well as negative cycle, we need to have not one but 4 such diodes in a proper sequence. I guess for few this may ring a bell. A combination of 4 diodes is mostly used in bridge rectifier. Now the question is, how do I combine it to form a bridge rectifier? Well, that's easy. We just need to draw a square box like this and mark the terminals on its 4 corners. Let the top and the bottom be for the AC source. In the right, let's have the positive terminal, and in the left, negative. Now let's consider this positive terminal. So I need to place my diodes on these two ends so that positive voltage comes out of this. So if I place the diode in this direction, positive half cycle would no doubt flow through this. Same is true on the other end of the AC terminal. This way we would get the positive half cycle in one side, and for negative cycle we just need to place the diodes in the reverse direction with respect to its opposite diodes. Just like this. Now if you just follow the waveform, we still haven't got a DC output yet. It's still pulsating. To remove this pulsating effect, we need to place a filter capacitor parallel to the pulsating output. For frequency of 50 Hz, we can use a filter capacitor of capacitance 1000 microfarad. So now you have a proper DC output of 12 volts on these terminals. We are not done yet. Our aim was to get 5 volt output. For this we need a voltage regulator placed at this 12 volt output. Let's use a LM7805 voltage regulator. LM7805 is basically a 3-terminal device. This here is the input, output and common ground. These two digits here imply the output voltage. So we have a voltage of plus 5 volt as output. Now having said that, your voltage regulator will constantly supply plus 5 volt output provided your input is always above 5 volt. Yes, now it's time to explain why we need a transformer of 12 volt instead of 5 volt. Basically the main part of the transformer involves copper windings along with an iron loop. There's a primary winding and then there's a secondary winding. The two leads of the primary winding are for the source voltage and the two ends of the secondary winding connect to the bridge rectifier. So how exactly a transformer works? To know this, we need to know the concept of electromagnetic induction. Basically, there is no actual physical contacts between the coil. So technically, when an alternating current flows through the primary coil, it induces electricity in the secondary coil through the principle of electromagnetic induction. The output voltage or current at the secondary coil is solely dependent on number of turns and thickness of the secondary coil, provided the EMF induced remains constant. Now, the question is when the EMF changes. The electromagnetic field changes as the primary coil voltage changes, that is the source voltage in your AC mains. So imagine I have a transformer of 230 volt to 12 volt. What it means is that output will be 12 volts as long as the source voltage remains at 230 volt. This is not always true. There are chances that your source voltage varies whenever there is a voltage fluctuation in the power plant or for many other reasons. This is the reason why we need a transformer of slightly higher range than required, so that when the source voltage comes down to a certain level, the transformer output may still remain in a voltage higher than actually required, so that the input of the voltage regulator always remains higher than its output. Please note the fact that a voltage regulator is a passive device. It cannot generate extra voltage. So if the input of the regulator falls down below 5 volt, then obviously the output will come down as well. I hope I'm clear why we have used a transformer of 12 volt instead of 5 volt. Now the question is, why only 12 volts? Are there no transformers with other ratings between 5 and 12? The answer is yes, there are, and of course you can use them. But most of the time we prefer a 12 volt and sometimes 9 volt as well. So now we have a 5 volt output here. Wait, there's one more small modification you may be interested in. You might want to have an LED indication to know whether your circuit is working properly or no. That is, place a 1 kilo ohm resistor in series with an LED between the positive and your negative terminals. And if the LED turns on, then your circuit is ready. That's all folks. But be careful while you make the connections. Try not to touch the AC supply once you have turned on your circuit. Use proper insulation wherever necessary. Thank you for watching. If you like my work, please hit the like button.